Alright, so yesterday, as I said, with integers, we did a Venn diagram to show the relationship between an integer and a whole number. And if you remember, the smallest group were the whole numbers. Okay? Whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we got into integers. Integers are all the whole numbers, but they also include 0 and then negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Today we're going to talk about another set of numbers, and they are called rational numbers. Okay, rational numbers are all the whole numbers. They're all the integers. And they're also another set of numbers. So, at the top of the next page in your notes, let's write the word rational number. The first part of the word rational is ratio. We talked about ratios earlier. There are 3 different ways to write a ratio. One is with a colon, one is with the word to, and then the third way is with a what? A fraction. So rational numbers. Or any number that can be written as a fraction. So, are whole numbers rational numbers? Yes. The number 5. How do you write the number 5 as a fraction, Landon?
5 over 1.
So that is a rational number. The integer, negative 3. Can that be written as a fraction? Yes, it would be what?
Would be 3 over 6.
Nope, that would be 1/2.
Would it be like 1 over 2?
Nope. Simply negative 3 over 1. The decimal, 6/10. How do you write that as a fraction?
6 over 10.
6 over 10. You take the number to the right of the decimal, that is your numerator, place value of the last digit as your denominator, giving you 6 over 10. If you had negative 3/10, how would you write that as a fraction? Owen?
Negative 3 over 10.
Negative 3 over 10. If you had 5 and 1/1600, how would you write that as a fraction? Olivia? Not 5 over. 5 and
1600.
the number to the right of the decimal, 16, becomes your numerator. Place value of the last digit is your denominator, so you have 5 and 1/1600. Okay? Negative 2 and 900. How would you write that as a fraction? Dakota?
Negative 2. Negative 2 over. Wait, not over.
Try it again, Olivia.
9 over 100.
Number to the right of the decimal is your numerator. Place value of the last digit is your denominator. Okay? So all of those are examples of rational numbers. Now, 3/4. That's already a fraction, right? Can that be written as a fraction? Yeah. Okay? So, rational numbers are any number that can be written as a fraction. That includes all the whole numbers. That includes all the integers. That includes every decimal. That includes every fraction. Positives or negatives. Okay? And so all these are examples of rational numbers. For about the next 2 to 3 years, most likely, you will only be working with rational numbers. That's a lie, because you will get into what are called irrational numbers. Okay? And those would be like repeating decimals and things like that. And then there's one other type, which would be real numbers, I think. And then I think there's one more. I can't think off the top of my head right now. Okay? But for a while, these are the types of numbers that you're going to be dealing with. Now, what are we going to do with rational numbers? Okay, well, we're going to be putting them on a number line. Now, if you have two whole numbers, or two integers, any two integers, let's say 0 to 1, and it's broken into 10 sections. Okay, so any two consecutive integers broken into 10 sections. Each section would be what fraction?
0.1 or 10.
What fraction?
Oh, like, out of 10, like 1/10, 2/10.
1/10. So any two consecutive integers broken into 10 sections, each section is equal to 1/10. How do you write 1/10 as a decimal?
0.1.
Or 0.1. Okay, so here I have 0 to 1, and it's broken into 10 sections. Where would A be located in? Landon?
The 5th line.
The 5th line over. 1, 2, 3, 4, 5. That is where A would be located. If B was equal to 7/10, where would B be located? Wyatt?
On the 7th line.
7th line over. 1, 2, 3, 4, 5, 6, 7. And there would be B. Okay, questions about that? Now, let's say we have 0 and -1. Now you notice, the negative is to the left of 0, correct? So let's say that it's broken into 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's say that C is equal to negative 210. Where would we find negative 210? Evan?
Would it be 2 from the 0?
It would be 2 from the 0. When we're at negative, we're counting backwards. Okay, so negative 2 would be right there, and there's where letter C would be located. If you had D is equal to negative 910, where would D be located? Owen?
9 places from 0.
The 9 places from the 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so there is where letter D would be located. Okay, questions about that? I just want to check something real quick, make sure we're only going to the 10th. Okay, now, let's say that with the same idea, but this time, let's say our number line is from 1 1/10 to 1 2/10. And it's broken into 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, here's 1 1/10. Here's 1 2/10. In that situation, each line would be worth how much? Evan?
100?
100. Okay? So like here would be 1 1100, because this is the same as 1 1000th, and here is 1 2000. That makes sense? Equivalent decimals. So if I ask you where is 1, if letter E is 1 1800, where would you find 1 1800 on that number line? Olivia? Or 8 places to the right of the 1 1/10, right? Going to get rid of these zeros because it's one thing you have to understand. You have to start recognizing understanding the concept of equivalent decimals. So 1 1800, okay? And I'm going to be honest with you. If I have this type of question on a test, you better believe the first thing I'm going to do is I'm going to take those to the 100th place. I think it makes it a lot easier. Okay, it's a lot easier. Where is 18 between 10 and 20? It's a lot easier to say that than it is, well, where is it between 1/10 and 2/10? Well, it's a lot more thinking involved. But if I put these zeros here, I think it makes a lot more sense. Goodbye. So 1, 2, 3, 4, 5, 6, 7, 8, or 11, 12, 13, 14, 15, 16, 17, 18. And so there would be 1 1800. Actually, when you were going over there, I thought you were going to puke. You were on a mission. I was like, okay, just make sure you open the door before you puke so you don't puke into the window. Okay? Now, let's say we have this. Negative 3 5/10, negative 3 6/10. Broken into 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now, where would you find negative 3 5,200. Well, I'm trying to find 3 in 5,200. The 5,200 goes to the 100th place. So what makes sense for me to do? Put these zeros here. Okay? So now where is negative 3 in 5,200 landed?
The second line from the 320, the negative 3 and 5,000.
2 places from the negative 3 and 5,200. So 51, 52, and there is where point F would go. Okay? Does that make sense? So that, you can do this, it's very simple if you have 2 consecutive integers or 2 consecutive rational numbers. Okay? That are broken into 10 sections. Very simple to do decimals, and also it's pretty simple to do fractions. So that's going to be one part of what your assignment's going to be. It's going to be placing them on a number line. Now, a second part of your assignment is going to be this. In this situation, is it broken into 10 sections?
No.
Now, so, can we very easily use decimals? No, decimals are very easy when they're broken into 10 sections. They're not very easy when they're broken into less or more than 10 sections. So in this situation, what we're going to do is we're going to work with fractions. Okay? So, since it is broken into 4 sections, what denominator do we want to use? We want to use a denominator of 4. Okay, very simply. Where would 3 and 3/4 be located? Steph?
Before 4?
Well, let's go from the, since it's 3 and 3/4, it would be, how many places from the 3?
3.
3 places from the 3. So if this is letter G, 1, 2, 3, letter G would be located there. What if they gave us this? Three and 2,500. Right now, is it very easy? Not really, is it? So, what are we going to do? Alyssa?
Change the decimal to a fraction.
Change the decimal to a fraction. We have 3 and 25 over 100. Okay, we can divide them both by. You can divide them both by 5. What else can you divide them both by?
25?
25. Don't forget your whole number. Now 25 divided by 25 is 1, and 100 divided by 25 is 4. So 3 and 2,500 is also the same as 3 and 1/4. 3 and 1/4 is located where? The first place beyond the 3. So there is where point H would be located. Okay? Questions about that? If we had this, -4 and 1/8. What 2 integers is -4 and 1/8 between? -4 and 1/8 is between what 2 integers? Declan?
4 and 5.
-4 and -5. Where is -4 located? A or B?
B.
It is located here. And here is where -5 would be located. Now, if we want to place negative 4 and 1/8 on that number line, how many sections do we need to change? Do we need to break that space into?
4.
Nope. Landon,
8.
how do you know?
Because it's 1/8.
Because the denominator is 8. Since the denominator is 8, we need to break it into 8 sections. Which means we're going to have how many lines?
8.
7. Because 1, 2, 3, 4, 5, 6, 7, and there would be number 8. Okay? So now, where would you find negative 4 and 1/8? Brian. Dakota.
Would be on the last mark.
Alyssa.
On the mark after the 4.
Which direction?
That.
Which is?
Left.
How many places?
1.
1. It's negative 4 and 1/8, so we're going to go for the 4. We're going to count 1 place to the left. So right here would be letter I. Negative 4 and 1/8. Okay? Questions about that? Okay, does that make sense? Owen,
Can we do the fraction one again?
which one?
The one where you turn the 3 and 4.
Where we had that? That one? Okay. Can I erase this? Sometimes they're not going to be really pretty. Okay, I'll give you one that's not going to be real pretty. Let's say we had this. Two and 3,600. Now, a different way you can do it, and this might be the easiest way to do it. This is that each one of these is how much? And between the 2 and the 3, it's broken into how many sections? 5. So each one is worth what fraction? 1/5. So here would be 2 and 1/5. Right? Here would be 2 and 2/5. 2 and 3/5. 2 and 4/5. 2 and 5/5, which is the same as 3. Who do you need?
I need Colton.
Colton.
Mom's here.
Okay. So now, where can we find out where 2 and 3,600 would go on this number line? We could change that to a fraction. Okay? Which would be 2 and 36 over 100. Okay? Now, what we would have to do is try to reduce this. We can divide them both by... Yeah, we could divide them both by 4, actually. Okay? Divide them both by 4, and you get 2 and 9 over 25. Okay? Now, what next thing we would need to do is we need to get equivalent fractions for each one of those. Okay, so 2 and 1/5 would be equal to 2 and something over 25 times 5 gives me 5. So this is the same as 2 and 5 over 25. 2 and 2/25, or sorry, 2 and 2/5, sorry, would be equal to 2 and something over 25 times 5 gives me 10. So this is the same as 2 and 10/25. This would be 2 and, do you see a pattern? 2 and 5/25, 2 and 10/25, 2 and 15/25, 2 and 20 over 25, And then here would be 2 and 25 over 25, which would be 2 and, or sorry, would be actually the same as a 3. But that still doesn't necessarily help us because we're trying to find the 2 and 3600. So another simpler thing to do, and this is what I would probably do. If I were trying to figure out where 2 and 3600 goes on that number line. Let's take this 2 and 1/5 and change it to a decimal. So 2 and 1/5. Divide the top by the bottom, put a decimal on a zero, move that decimal up. 5 goes into 10 2 times. 2 times 5 is 10, subtracting it 0. So 2 and 1/5 would be the same as 2 and 2/10. Make sense? 2 and 2/5. Divide the top by the bottom, put a decimal on a zero, move that decimal up. 5 goes into 20 4 times. 5 times 4 is 20, subtract, get 0. And so this is the same as 2 and 4/10. Now, we want to find 2 and 3600. It's going to the 100th place, right? So 2 and 2/10 is the same as 2 and 2000. 2 and 4/10 is the same as 2 and 4000. Is 2 and 3600 between these two? Yeah, it'd be located somewhere about there. 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 36, 39, 40. 2 and 4000. Okay, so you're estimating where 2 and 3600 is between 2 and 2000 and 2 and 4000. Okay, Owen? You're looking like, what are you talking about, right? Okay, let's do another one. And these are extreme cases. Okay, I'm giving you the worst case scenario so that easy ones are easy. Okay? Let's do another one here. Let's say we have -4, -3, and let's say it's broken into 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and let's say we want to find out where is -3 and 6500 at. We know it's somewhere between -3 and -4, but we don't know where. Agreed? So, I'm broken into 8 sections, so this would be -3 and 1/8, -3 and 2/8, -3 and 3/8, -3 and 4/8, which -3 and 4/8 is the same as -3 and 4/8 is the same as -3.5, -3 and 5/8, -3 and 6/8, -3 and 7/8. Okay? Sorry, not 1/4, 1/2. Sorry about that. Okay, once again, worst case scenario type of problem. Alright? Probably won't have anything this difficult, but if you can do this, if it makes sense, it makes everything else simple, okay? Alyssa? Yeah. So, what I'm going to do, I'm going to find out what decimal -3 and 1/8 equals. Okay, Ellen? I'm going to change that fraction to a decimal. So, -3 and 1/8. I'm going to divide the top by the bottom, put a decimal on a zero, move that decimal up. Right? Does that make sense? Yeah.
Where did you get the 1 and 0?
Divide the top by the bottom, 1 divided by 8, and then put a decimal out of 0. Right? Do you understand that? Are you sure? Then I divide the top by the bottom, change it to a decimal, right? You understand that? Does 3 go into 1? No. So I put a decimal and add a 0. Okay? Now I move that decimal up 8 goes into 10 how many times? 1. 1 times 8 is 8. Subtract. And I get 2. Add another 0. Bring that 0 down. 8 goes into 20 how many times? 2. 2 times 8 is 16. Subtract, I get 4. Add another 0. Bring that 0 down. 8 goes into 40 how many times? 5. 5 times 8 is 40. Subtract, I get 0. Don't forget my whole number. And so this place here would be -3 and 125,000. So that means that each space is what decimal? What decimal is it from here to here? 125,000. Does that make sense, Owen? So, to go from here to here, I could change the fraction to a decimal. I could change the 3 and 2/8 to a decimal. Or, I could simply do what? Autumn?
Add 125,000.
I'm going to take this -3. I'm going to have to worry about the negative. I'm going to take the 125,000 and I'm going to add another 125,000 to it. 5 and 5 is 10. Carry the 1. 2 and 2 is 4. And 1 is 5. 1 and 1 is 2. Bring the decimal straight down. And so now this one here would be -3 and 250,000. Does that make sense? To go to here, I'm going to add another 125,000 to it. 5, 7, 3. So here would be -3 and 375,000. Does that make sense? To go from here to here, I'm going to add another 125,000. 10, 7 and 2 is 9, 1 is 10, carry the 1, 3 and 1 is 4, 1 is 5. That gives me 500,000. To find the next one out, what am I going to do? Add another 125,000 to it. And that gives me -3 and 625,000. What am I going to do? Add another 125,000. 10, 2 and 2 is 4, and 1 is 5, 6 and 1 is 7. Now it's going to be -3 and 750,000. I can stop at that point because each one of these goes to the 1,000. All right? How do I change this to 1,000? Wyatt?
Add a 0.
So, approximately, where would -3 and 650,000 go? It would go approximately between what two fractions?
The
Can you see
3
it?
and 7/8 and 3 and 6.
Between these two?
Yeah. Okay. Wait, no. The 6 and the that's what I meant.
It would go between these two fractions. Somewhere about in the middle. Okay? And so that's where this one would go. Okay? All I did was find out what the decimal was from here to here by changing this fraction to a decimal, the first one. Once I found the first one, then I knew that every other one was the same equivalent decimal. So I just kept on adding the value of the value from each place, and just kept on adding it on. Does that make sense, Owen? Okay. Questions about this? Okay, open up your books. To page 215.